Hello everybody, it's Mrs. Pound, and we are working on Chapter 3, Measurements in Chemistry from BJU Chemistry 5th edition. Our topic today is going to be the first part of Section 3.2 about measurements. There will be 2 videos for this section of your book. So our objectives for today are to explain why accuracy and precision are important, describe the factors that affect precision in measurement, and evaluate the accuracy and precision of measurements. So accuracy indicates how close a measurement is to the actual value. This is like if you're shooting at a target with bow and arrow, how close to the bullseye are you? Are you very accurate, or are you all over the place, far from the center? Okay, that's a good picture of accuracy. Accuracy, when we evaluate it, we're going to use a formula called percent error. And percent error is the absolute value of the difference between the measured value and the accepted value. So what you measure experimentally minus what you should theoretically get, divided by that accepted value, the theoretical value, times 100%. You will find this formula on the back of your reference table. So it's not something you have to memorize. It is on the back of your reference tables. So a typical problem might be you measure the mass of the product of a chemical reaction to be 3.80 grams. According to your theoretical calculations, you should have obtained 3.92 grams. What is the percent error of your work? So we're looking for percent error, so we think, we have a formula for that. So go ahead and write this formula down in your notes, because we always, when we start a problem, we write the formula. So write the percent error formula. Now, looking at the problem again, you measured the mass of the product of a chemical reaction to be 3.80 grams. So this is your measured value, 3.80. According to your theoretical calculations, you should have obtained 3.92 grams. So this is your accepted value. What is the percent error of your work? Well, we take those two numbers and we plug them into our equation. 3.80 grams for our measured value, 3.92 grams for our accepted value. And remember, that goes in 2 spots. We do the math. So on the top, we subtract and find the difference. It becomes negative 0.12 grams divided by 3.92 grams. Now we can actually cancel out those units. And we end up with 3.1%. Remember, this ends up being a positive value because we took the absolute value. We could leave it to show that you were low by 3.1%, but we usually do this as an absolute value. So when we do this calculation, the smaller the percentage of error, the more accurate the measurement is. The closer you are to 0, the more accurate the measurement. Now, another aspect of measurement is precision. This is an evaluation of the exactness of measurement, repeatability. So if we're shooting at a target with arrows, that's where we have a cluster of arrows all in one spot. They're all really, you're hitting the target repeatably in the same place. That doesn't necessarily mean that you're accurate, that you're hitting the target where you're supposed to at the bullseye, but you have a nice cluster. Factors that affect the precision of an instrument are mathematical errors. Maybe you have performed a mathematical error in one of your calculations, and so your precision is off, so all of your measurements are not close. So always make sure you're using your calculator right. Always double check calculations. Improper calibration. If you look at these weights, they're a little rusty and have some chinks out of them. So if it was used to calibrate your instrument, it might be off. Also, let's say you're doing measurements with my balance. Did you remember to zero it, or did you zero it when you shouldn't have? And that can all affect your measurements and make them less precise and not agree with your other measurements if you make a mistake like that. Procedural error. On this ruler, did you start at 0 or did you start at the end of the ruler for some of your measurements? Was there variations in how you were using your ruler? So those can all affect your precision. If you start at the end of the ruler for one measurement but at 0 for another, that's going to affect your precision and your accuracy for that matter. So all these things that affect precision also affect your accuracy. So let's take a look at these numbers. It says a gas's density, or this example, a gas's density is experimentally measured to be 2.865 kilograms per cubic meter, 2.852 kilograms per cubic meter, and 2.860 kilograms per cubic meter. The actual density is 3.124 kilograms per cubic meter. So let's take a look at it and evaluate this data for precision and accuracy. The first thing I'm going to do is I'm going to look at these numbers that were our measured numbers. And I'm going to look at those, and those are all pretty close together. So I would say that the measurements are precise. They're repeatable. However, if we look at the actual density of the gas, 3.124, our answers are a little off, aren't they? So even though our measurements were precise, they are not accurate. Okay, so that's how we use precision and accuracy to evaluate a group of numbers. Now, there is a large space there. What we're going to do is we're going to use this problem to find percent error first thing in class. So our objectives today were to explain why accuracy and precision are important, describe the factors that affect precision and measurement, and evaluate the accuracy and precision of measurements. Now, if you're listening to this, go back and next to accuracy, I want you to draw a bullseye with arrows all in the center. And next to precision, I want you to draw a bullseye with a cluster off of the center of arrows hitting the target to show that you were listening. So don't forget your 5 questions, and we'll finish that one problem in class.